Not sure. There we go. We are live. We're back, ladies and gentlemen. My name is Sunny Ray. This is the Sunny Ray Show. Thanks to our sponsors, Raz Rocket and GTM Ventures. Today, I'm joined by Saurabh Mishra. Saurabh, how are you doing today?
I'm doing fantastic.
Awesome. I'm really pumped about our talk today. Why don't you tell people just like one or two lines on the company that you're building, Code Flash, like what you do, and then we'll just kind of put a pause on it, and we'll come back to that near the end of the talk. But I like to give people a bit of a heads up on where we're going.
Yeah, I'm Saurabh. I'm building Code Flash, and we are solving the problem of making all generated and human written code always be optimal and be performant.
Nice. So with that said, sort of why don't you maybe just share, as I was saying before, is for me the backstory is always super interesting before we get into the tech and entrepreneurial journey. You grew up in India and earned an electronics engineering degree from IIT. I used to sell robots to the IIT, and I know from experience that IITians are by far some of the smartest people I've ever met. I read a statistic once that it's harder to get into IIT than it is to get into MIT, statistically speaking. So, but before eventually landing in San Francisco, right? So, what was the journey like? How did you always want to live in Silicon Valley? But share a little bit about maybe the backstory from where you're coming from.
Yeah, just quickly, I think so. I think when I was a kid, I was super curious. So I was just like taking stuff apart, like just trying to build new things. Just like I think it was like a pretty cool moment in my life. And I think that's sort of like got me really interested in technology and got me really interested in like how computers work. And it was a super cool moment in time. And I think from there, I realized that, hey, you know what, I really want to understand how computers work, like in like full depth. So that's why I started like studying electronics at the IIT and had a good time over there. And I did like both electronics and also understood the software part of it. And that's like what eventually got me to NVIDIA, where I was like building tools that other chip architects, GPU architects could use to like optimize the GPU architecture itself. And that was a fun time. I think it was like building software for like designing hardware, sort of at the intersection. And luckily for me, at the same time, that's like when the first wave of machine learning was taking off around 2016. And that's like when I got really interested in that because I think that solves the intelligence problem. And I've always been really interested in like learning and like how things work. So that's like when I got deep into it, and I really wanted to pursue that really thoroughly. And so for that, I came to the US to do my master's at CMU to just go very deep into that, and had a great time over there. Like just built all my foundation on like understanding how all these things work. And I think around the same time, I was also getting interested in like entrepreneurship. So a bunch of my friends had started companies, and yeah, they wanted me to join. And then that's like when I really got into it and like started considering it seriously. And CMU also supported me through like a fellowship that like got me the visibility into like the whole Silicon Valley ecosystem. And I think that's like how I got super interested. And like right after CMU, I joined a startup over here at a seed stage. And yeah, that's like where I got to sort of like do this like budding entrepreneurship thing to like act as like an entrepreneur within this company and also like do all the machine learning hard heavy stuff out there. And that's like where I sort of started, and like the startup did well. I grew really quickly over there, and I think that's like where my passions towards like entrepreneurship really started, and like I think my deep tech foundations really came into play as well to understand. And then like that's like where I think like sort of like the background of my journey.
Oh man, that's crazy. That's interesting. I have a bunch of questions that I had around. Well, I guess a bunch of things. So first of all, you're in electronics engineering, right? That's a long way from AI and software startups. What drew you to that field initially, and what did you think your career was going to look like when you graduated?
Yeah, I think so. I remember, I think when I was in like undergrad, like my first year, I was just doing everything in the whole world. So like doing sports, like quizzing, like and music. And then like my grades came over and I'm like, hey, you know what, oh, I think I need to like get a bit serious. And then I'm like, okay, you know what? Okay, so I came to the college to really understand electronics. So that's like when I really focused on that. So really dig into like everything about electronics. But at the same time, I was like always really passionate about the software. And I think like the bridge between electronics and software was not that much for me, because I think I thought of about it as like understanding just the whole stack, understanding like the physics of it, like how chips are made, like how electronics work, like and like the circuits work, and then from there going to computer architecture, and then like actually knowing the programs and how do they actually call the computers and all that, and from there going up to the application stack. So that's like how I thought about it, and I think having this formulation made me a much better engineer, because I understand like everything in the whole stack from like the physics level to the actual like system architecture level. So I think that's like how I think about it, and that's like my one of my passions is just to understand the whole world, and this actually just like really fit into that whole thing.
And then you also said that you went, or I was reading that you did your master's at Carnegie Mellon,
Mm-hmm.
and you touched on that. But there you won the James R. Swartz Fellowship, right, for entrepreneurship.
Mm-hmm.
And I think you touched on this a little bit, but was the entrepreneurial bug already biting you at CME, or were you still thinking you'd climb the corporate ladder? And how did that kind of unfold for you?
Yeah, I think so. I think as I joined CMU, I thought this would be like a great moment to really go become serious about this. So I think like in India, I was like, hey, I should consider this, but it was like, yeah, sort of like I was passionate about it, but sort of like somewhat like a fantasy as well. Yeah, maybe I would do it, and I'm a sort of like don't really know how this all this works. When I came to CMU, like I was pretty serious about it. I remember like looking up even before I joined CMU, like what are the resources that are available for us, and like understood that there was this like entrepreneurship center. So like really tried to associate myself with that. So I think I just got very serious and intentional about this part, and that actually like really helped me, because then I think like I remember like before CMU, I was like an engineer who could like write code and like make things happen. But after that, I think this intention made me learn like the business part of things. Understand, hey, it's not just about the code; it's like customers. There's like so many other things that happen. So I think that's like how it grew. So I think I was always like passionate about it, and like just me being intentional about that really helped me grow quickly.
Interesting. And then you mentioned that your first big role out of grad school was at NVIDIA. So
After undergrad.
after undergrad, okay, got it. So, you were, I think, building performance tools for chip architects. What was that like as a, young engineer? Like, what did working so close to the hardware teach you about how software actually works?
Yeah, I think it's super cool, because if you think about it, at the end of the day, everything we run just triggers or switches some transistors in a chip somehow. So I think like, just like having this insight about like in GPUs, like how graphics actually flows through the GPU, and like how does it render into everything, and then like how do we actually optimize this, uh, and not just optimize this at like small thing, but at a whole chip level scale. And then we were also working at like the bleeding edge GPUs that were coming out, and so I think it like really like basically threw me into the deep end of like the main thing that NVIDIA does is performance. Like its GPUs are the fastest, and so just like going to this and seeing the scale of the problem and understanding like the whole GPU architecture, and then actually building things that actually optimizes it, like I think it really helped me appreciate like the vast nature of the problem, and just like learn quickly and then build like we also did a lot of like research projects over there to like actually improve GPU performance using AI. It was super early, but I think that's how I really understood and grew really quickly as well.
And then at Meta, you were literally inside one of the world's most sophisticated AI systems, right? Working on recommendation pipelines for over 1 billion people. So what does it feel like to operate at that scale? And, what cracks in the foundation did you start noticing?
I think it was super interesting. I think like at meta scale, they have like billions of people using it. And it makes things really interesting, because you can essentially just have hypotheses and run experiments and then validate those experiments really quickly. So doing this at that scale like makes each decision very quantitative. So you say, hey, this will make things better. Hey, does it actually make things better? You can just like test that, because you have so many people using Meta products, and that really makes like improvement of product much more rigorous and better. So that was like a very interesting sort of a thing, and like the scale of meta is just unprecedented. So you could just like launch experiments. So I think like I remember just like running one experiment that like raised the DAU, like daily active users for Instagram by 1%, which is crazy. Which is the sort of things that you can do at like meta scale. So it was like a very different experience. Like you're running like ML pipelines that process, I don't know, 10, like that are running on 10,000 nodes or something, which is quite enormous.
Yeah, and you've also described yourself as someone who has always been performance minded, right? Even as a student, you'd ask yourself how far a piece of code could really go. Where do you think this obsession came from? Was there a moment again early in life when efficiency became an obsession?
I think so. I think it's just sort of like from my childhood in some ways. So my father was a mechanical engineer, or is a mechanical engineer. And if you think about things, like if you think about engineering, like like you can make. I mean, we have had jets for a long time. We have had cars for a really, really long time. We have computers for a really long time. But then progress happens, or like engineering progress happens when we like essentially increase this parameter, which is efficiency. So how much can you do with like less? And that's how you think about it. Like that's the sort of sure. There's like invention part of it, and then there's efficiency on top. So, and I think like just like talking with my father and also just like other engineers made me realize like how important efficiency was towards good engineering design. And that's something I felt has been missing in software design and software engineering. Um, so that's sort of like been my motivation, and that's like what got me really interested into like efficiency, because I think like efficiency, peak efficiency, is like the peak of like engineering in some ways, and that's like what really drew me in.
Interesting. So you've also talked about seeing slow code everywhere you worked, right? But millions of engineers work at those same companies that you've worked at and don't quit to start a startup. So what finally made you say, I have to do something about this?
Yeah, I think um, so. I think my passions were around doing a startup for a long time. I think when I did like CMU, it was in 2018, and that's like when I got serious about it. But I think like inspiration takes time to strike sometimes, even when you know you want to do it. You don't really know what to do, or the timing is not right, or you have other things going on. So I think that ends up happening. But I think this thought really lingered in my mind that, hey, I do have to do this for a long time. And then I think like I got really serious about doing this, and I was like running sort of like experiments, like ideas that did not work out. I did like tried pursuing it like more seriously. But then essentially what happened was when GPT-4 came out, I was sort of playing with it, and then it was like a very big step change in what these models would do with, especially coding. And I think I was playing with it, and then just realized that it actually worked fairly well for optimizing performance of the code. I think that was sort of like the aha moment for me, which is I realized, hey, you know what, this is the final thing that was missing in this problem, where so efficiency has always taken a backseat in software engineering because just of the amount of effort it would take to go and optimize all the things out there. So what usually people do or engineers do is they like, okay, you know what, let me focus on my main thing, which is feature development, like creating new things. And then if it becomes a problem, then I will go and look into efficiency. So essentially what that creates is there's a lot, like whenever you build something, think of it as you're just like creating a lot of slow code and slow systems in your wake. So what I realized was, hey, you know what? If now LLMs could generate optimizations, which may or may not be correct, but then we also pair it with verification systems that actually measure performance and then can accurately say that, hey, this is 50% faster while still preserving correctness, then basically, as you make a product out of this, then you can systematically solve the problem of making all the new code be efficient. So that was like the aha moment. I remember like I could not sleep for a whole week or like at least 3 4 days because I was like so excited because I understood like what this meant, um, as like sort of like the missing piece in this holy grail. So yeah, that's like when I got like, holy shit, this is like big. and I really need to pursue this. And I think like started talking with people, started talking with customers, people who could build this with me, like investors, and then there was like just like a lot of positive signal I was getting. So I realized that hey, this is gonna be big, and that's like when I just like committed to doing this, and yeah, just took the plunge on this.
So was it a hackathon in 2023 where you it demonstrated that LLMs could, optimize existing code, or did that come before or after?
Yeah, I think it was. I remember like GPT-4 basically dropped, I think, on a Thursday, and then I was like working on some startup ideas, and I was quite kind of phased because hey, like I've been trying this so hard, it's not really going somewhere. What do I do? Sort of it's like where I was, and then yeah, GPT-4 came out. I'm like, hey, this is cool, and yeah, I think one of the houses I knew, AGI House, so they were hosting like a GPT-4 hackathon. I'm like, yeah, let's try this out. And I remember just like going to like playing with GPT-4 like Friday evening to see what things it can do, and just realize that hey, it can actually optimize the performance of code. And
Interesting.
yeah, so
Eh,
that's like when
eh,
I went to the hackathon, presented, I think everyone liked it over there.
And you say people were shocked, right, that an AI model could improve existing code. But why do you think that idea was so counterintuitive, even to seasoned engineers?
Because I think like optimization is a really hard problem. I think I would still say it's a hard problem because like if you think about optimization, it's sort of like solving the expertise problem. So, and the LLMs were considered, especially early on. I think like now, the like people's expectations about it are changing, but even right now it's a problem. But earlier it was like, hey, LLMs write terrible code. They can make all these mistakes. They are like hallucinate, and then all these bad things happen. So how can LLMs actually make my code expert level? So that's like where the skepticism came through. But I think actually what's going on right now is that people like the amount of slow code counterintuitively is actually increasing in the world right now. Because as people rely a lot more on these tools like Claude Code, Codex, they churn out things that work, they like move things around, and they don't really understand what's going on with respect to performance or efficiency of the code because they don't even understand what's going on with the code, right? So what we see actually is like team who really rely heavily on these things end up writing a lot more slow code than like what an expert would who actually paid attention. So this problem is just like even increasing right now.
Interesting. That's very fascinating. So you built a C++ tool at NVIDIA, right? That improved GPU performance by 15%. Is that correct?
Yeah, I think so. I think it was just like going into and understanding like dynamic runtime information. So as things execute, like understanding how what is happening within the architecture of the GPU, like what are the bottlenecks like and things like that. And I think I don't think it was a while ago. I think Volta architecture. I think we improved like async compute by a lot through that better observability of what's going on.
That's crazy, man. Like you move the needle at Instagram by 1%, move the needle at Nvidia by 15%. So I know we've got only a few minutes left, Sora, but I'd love to, by the way, have you back on like a part two. I haven't even scratched the surface with all my questions. But let's not leave people hanging. Tell them a little bit more about Code Flash. Like, who's the ideal kind of customer? What kind of pain points are you guys solving?
Yeah, so I think like we make sure with Code Flash, essentially we automate performance optimization. The idea is that we want engineers to be able to like be really productive. Be able to write a lot of code, but at the same time have all that code be efficient and performant as well. So the way Code Flash works is it runs in the background as a Claude Code extension or as a GitHub action integration. So whenever someone creates a pull request, like Code Flash looks at all the new code that's been written and asks this question: Hey, is this like the most optimal it could have been? And does this search over all the different possible ways to implement this and figures out the most optimal one? And basically, when it proves that something is really optimal and is much better than before and is like readable and is correct, it creates suggestion that is reviewed by either agents or by humans. And then, like basically, with that, we can have continuous optimization, which is all the new code can be optimal. And I think what we have seen is this is really useful for companies who run at scale. So like you don't have to firefight like slowness in the future, but essentially like even before you ship things, it's always optimal. And I think we have seen that this is really, really valuable for CTOs or like engineering leads, because we basically move the needle at a company level scale, saving costs, decreasing latencies, and making sure that every engineer's and every agent's code is always expert level.
Unbelievable. That yeah, a great yeah, great interview. Thank you sort of for your time. If people want to double click on you, the company, do you want to share maybe the domain where you are you on LinkedIn? Where's the best place for people to chat with you?
Yeah, I think LinkedIn is the best. Otherwise, they can also check out the website at codeflash.ai.
Awesome. Awesome. All right. Sounds good. Sort of just stick around for 1 second. I'm going to bring this to a end. Thank you all for tuning in, and until next time.
Thank you.